Good morning, my dear students. Today, again, we are going to learn one of the important concepts in laws of motion, that is law of conservation of linear momentum. So, law of conservation of linear momentum. We will also call it as LCM, law of conservation of linear momentum. So, for this, consider two marbles M1, M2, and their initial velocities are U1 and U2 moving in the same direction on a straight line. And also consider that speed of the first marble is more than the speed of the second marble. U1 is greater than U2. So definitely M1 will go and hit M2 after some time. So M1 exerts some force on M2, that is force on 2 by 1. If you call that as force on 2 by 1, if you call it as action force, then 2 also exerts some force on 1. 2 also exerts some force in the interaction time, that is force on 1 by 2, which is F12. Force exerted by 2 on 1. F122 means force on 1 by 2. So we know that from Newton's third law of motion, if the first body exerts some force on the second object will exert the same amount of force on the first body. So if this is action force, that action force is on 2, the reaction force will be on 1, which are equal in magnitude, opposite directions, acting on 2 different bodies. So action force, I should write it as minus of reaction force from the Newton's third law. So to every action, there is an equal and opposite reaction. So the action force is equal to reaction force. Action force means force on 2 by 1, which is called F221, is equal to minus of force on 1 by 2. Now, to get these forces, I'm just going to this table. So here see, we have two marbles, M1 and M2 are their masses, U1 and U2 are their initial velocities before the collision. And we know that they are moving in the same straight line, in the same direction, and U1 greater than U2. So definitely one will go and hit the 2. So that is, this is during the collision. Let us consider that the collision is occurring for a small interval of time, some t. So that is, the collision is taking in a small interval of time t. And after the collision, first object velocity is v1, second marble velocity is v2. And so then see, momentum of the, so marble 1 and marble 2. Momentum of the first marble, momentum before the collision. So BC means, we should remember, momentum before the collision M1 U1, momentum after the collision we should write it as M2 U2. And momentum after the collision, momentum of the two objects after the collision, M1 V1 and M2 V2. Now change in momentum for both the objects. So change in momentum. So change in momentum means change in momentum of the marble 1. So now I want to write the change in momentum of the marble 1. So marble 1 final momentum is this one, M1 V1, that is this one, and M1 U1 is the initial momentum. So change in momentum means we should write it as M1 V1 minus M1 U1. And similarly, change momentum for the second object, we should write m2 v2 and m2 u2. So m2 v2 minus m2 u2 is the change in momentums. Is the change in momentums. So fine. Now this change in momentums are occurring in very short interval of time, and this collision time also we are considering for very short interval of time, just before the collision, just after the collision, and this collision interacting time is t seconds. So I am going to write change in momentum by time. So change in momentum I have here, and this change in momentum is occurring in t seconds. So we are writing change in momentum by time. So whenever a quantity changes with time, we'll use the word rate of change in momentum, that is delta v by delta t, which is written as m1 v1 minus m1 u1 by t is equal to m2 v2 minus m2 u2 by t. So rate of change of momentum for the first marble means it's change in momentum by time, and rate of change of momentum of the second marble means it's change in momentum by time. You should write it. So then from the Newton's second law of motion, force is equal to rate of change of momentum we know. So force on 2 means the rate of change of momentum of the second object we have to write it, that is m2 v2 minus m1 u1 by t, and here we should write it as m1 v1 minus m1 u1 by t, and this interaction time is same for both of them, gets cancelled, gt gets cancelled, then we get m2 v2 minus m1. So bring r m1 u1, and so this will be m2 v2 minus m2 u2. So m2 v2 minus, so just this time gets cancelled. So the equation will be like this, and bring all u1 u2 terms one side, m1 u1 already we have here, and bring this minus m2 u2 right side, m1 u1 plus m2 u2, and bring this minus m1 v1 left side, m1 v1 plus m2 v2. So means this is the total momentum just before the collision. Before the collision, total momentum of the system is m1 u1 plus m2 u2, and total momentum after the collision is m1 v1 plus m2 v2, m1 v1 plus m2 v2. So the sum of the momentums before the collision is same as that of sum of the momentums after the collision, means total momentum before the collision is same as that of total momentum after the collision. So total momentum remains constant. If anything is constant, that is called conserved. So this is called conservation of momentum. Here the momentum of the system of two bodies, momentum of the system of two bodies, that is m1 u1 plus m2 u2. This is just before the collision. Total momentum of the system we will find it, that is m1 u1 plus m2 u2, which is same as that of total momentum after the collision, m1 v1 plus m2 v2, means total momentum after the collision and total momentum before the collision are equal, means it is not changing. It is not changing means total momentum is constant. If it is anything is constant, we will use the word conserved. So that is called law of conservation of linear momentum. So the total momentum remains conserved in this system. We can write it. So, and this is our system we have to consider. This is my isolated system. This is my isolated system. So isolated system means only internal forces. In this system we have two objects, one is m1 and m2. Just two objects are interacting with each other, and there is no other external forces acting on it. There is no other forces in this box of the objects. Only they are only interacting interacting themselves. These are moving like this and interacting after some time moving like this. So only internal forces are acting and there is no external forces are acting on the system. Whenever if you consider a system and on that system if there is no external force acting on the system, then total momentum of the system before the collision must be same as that of total momentum of the system after the collision. You can write it. So that is law of conservation of linear momentum. We can write for two objects, that is m1u1 plus m2u2 is equal to m1v1 plus m2v2. If we have one more object also, you can write it m1u1 plus m2u2 plus m3u3 is equal to m1v1 plus m2v2 plus m3v3 also you can write it. This is called law of conservation of linear momentum. And it's next class we can see another concept. Thank you all. Hello students, good morning all of you. Again we are going to learn a very interesting concept in laws of motion. So that is, see children, why does a cricket fielder pulls his arms while catching a fast moving ball? Fast moving cricket ball. Or why does a pole vault jumper land on a thick mats of foam? Why it is safe to jump on sand rather than cement floor? Why eggs dropped on concrete floor breaks but on cushioned pillow will not break? So to answer all these questions, we should learn a small and interesting concept that is called impulse and impulsive forces. See children, why does a cricket fielder pulls his arms back while catching a fast moving cricket ball? Why does a pole vault jumper who uses to carry on pole and jumps from certain height on a thick mats of foam, why it is safe to jump on sand rather than cement floor, and why eggs dropped on the concrete floor breaks but on the cushion pillow will not? To answer all these questions, we should know a small concept that is called impulse. Impulse is equal to the product of net force and time. It is the product of net force into time of interaction. How much time the net force is acting on the body. Simply remember, my dear students, impulse is nothing but it is a product of the net force acting in very small interval of time. So impulse, you know the letter J, that J is equal to net force F net and the interaction time delta D. So, but from the Newton's second law, we know that net force is equal to rate of change of momentum produced on the body. So we know this formula, F net is equal to delta P by delta T. See children, when we are going on a cycle, we will have some mass. We want to increase our speed while going on that road. What do we do, my dear students, to increase our speed on the road? What do we do? Yes, your guess is correct. We pedal the cycle with greater and greater force. We pedal the cycle with large amount of force. We are increasing our speed. So we keep on going with the greater speeds. Means we have a mass and our velocity changing the product of mass into velocity gives change in, okay, that is mass into velocity gives momentum. That momentum is changing in some interval of time. So change in momentum by time we totally call it as rate of change of momentum, that is directly proportional to the net force applied by you on the bicycle. If we apply more and more force on the pedals of the bicycle, the speed of the bicycle increases rapidly. So F net is equal to delta B by delta T. Similarly, you want to stop the moving cycle also. To decrease its speed also, we should apply a force, but that is retarding force. We apply more force, its momentum decreases by more amount and quickly comes to rest. And if we apply the more force to that means this rate of change of momentum may be positive or negative. Or we want to increase the speed of the car, we turn the steering, turn it means the engine is exerting large amount of force, so speed increases. Or we are applying the brake suddenly, means we are applying the brake suddenly, we are applying more amount of force, greater amount of force in a short interval of time, then the momentum decreases in that time. So rate of change of momentum is called force. So this is from the Newton's second law. It is indirectly nothing but m into a. So here in this F net, I can write delta P by delta T. So delta P by delta T, and here delta T gets cancelled. Then impulse J is equal to, so delta P I got. See children, we already clearly know that delta P is equal to the change in momentum. So this delta P is nothing but J, we got it. So impulse is equal to the change in momentum. Means we can write impulse is equal to product of force into time, or we can also write indirectly it is equal to delta P. You can write it, this delta P you can write it as, this delta P you can write it as mv minus mu also. And see children, force is a vector physical quantity. Vector into scalar gives a vector. So impulse is a vector physical quantity. So now we can see the SI units of impulse. And see my dear students, we know that impulse J is equal to F into T we are writing. So SI unit I want to write now. So SI unit is equal, SI unit of impulse means we should write the SI unit of force and we should write the SI unit of time. And what is the SI unit of force children? Yes, you are correct. SI unit of force is Newton and SI unit of time is, what is that children? Second. So Newton symbol is N and second symbol is S. Newton into second, or simply you can write Newton second also. Newton second also we can write it. Okay students. Otherwise, we can write this as delta P, force into time means we will get the delta P. The delta P means what do you write children? M into V minus U. Or you can write mv minus mu. Means mass unit, you write it kilogram. Initial velocity some 20 meter per second. And final velocity some 60 meter per second. Again, change in velocity meter per second, you will get kilogram meter second power minus 1 is the unit you will get. You can write simply Newton into second, or you can write kilogram meter second power minus 1. So that is SI unit. And CGS unit of impulse I want to write it. CGS unit of impulse. To get the CGS unit of impulse, we should write the CGS unit of force and we should write the CGS unit of time. Tell me children, what is the CGS unit of force? Yes, you are correct. So CGS unit of force is dyne and CGS unit of time anywhere second only. So it will be dyne into second. So it will be dyne into second. Or we can write in terms of change in momentums, mass CGS unit is, what is that children? CGS unit of mass is gram, we know. Okay, gram. And velocity CGS unit is centimeter second power minus 1. So that is dyne into second, a gram symbol G, centimeter second power minus 1. And see children, force is a vector, so impulse is a vector quantity. So we will write impulse J bar is vector physical. Simply vector, you remember, it's sufficient. So that is about impulse. What is that we have seen. So now we can go the answers for our questions. We can go for answers of the questions. Why does a cricket fielder pulls his arms while catching a fast moving ball? And all those we can discuss. Listen carefully, my dear students. So now I want to discuss first clearly from the dropping eggs. So why egg dropped on the concrete floor breaks, but cushion pillow will not break. So dropping eggs, activity number 8. Dropping eggs, we can see. Now I am considering one concrete floor. This is cemented floor, you know. This is called concrete floor. What is this, children? Concrete floor. And this is what do you know, children? This is a cushioned pillow. So this is a cushioned pillow. And see children, this is one egg, and this is another egg. So second egg, all at the same height, and we are dropping them on the cement floor and on a cushioned pillow. Initially eggs are at same height. See, when the egg comes to here, from here to here, when it comes to here, it pick up some speed. Consider it has picked up some 20 meter per second speed it has picked up, and to here it pick up a speed of 20 meters per second, because since both the eggs are dropping from the same height, they will develop the same speed just before hitting the concrete floor and just before hitting the pillow. And after hitting, the final velocity will become 0. And here also, after hitting, the final velocity will become 0. And we know, children, impulse J is equal to change in momentum. The change in momentum, impulse is equal to the product of net force. Single force won't exist, net force only. It's a product of force into time. So if we want to give some change in momentum, we should give that as the product of force into time. Same change in, see here initial mass of the egg, here m, here also mass of the egg is m. Initial velocity is same, final velocity is same. Here also initial velocity is same, final velocity is same. So same change in momentum we want to give. But here when the egg falls on the concrete floor, it comes to rest very quickly. Means this change in momentum is same in both the cases. Change, I want to write here. So change in momentum is same in both the cases. So because same change in momentum, but here the egg comes to rest quickly, so means the time of interaction is less for the same change in momentum. That change in momentum is the, what do we know, children? Change in momentum is the product of force into time. We are saying same change in momentum is occurring in both the situations, but when the egg falls on this cushioned pillow, it takes long time. It takes long time to come to rest. It takes long time to come to rest, because somewhat it will move up and down. It covers more distance. Here it comes very quickly, long time. Here less time. Time taken is less. So less time it takes to come to rest. Less time. When the time is less, force will be more. So less time, the egg experiences large force on it. The egg experiences large force on it. Experiences the large force on it. So it will break. It will break. And here long time is more. Okay, so even though change in momentum is same, even for change in momentum is same in both the cases, that change in momentum we are giving as delta p. It is a product of force into time. So long time takes comparing to here. So more is the time, less is the force experienced by it. Long time to come to rest. So interaction time is more, experiences less force. So experiences less force. So the egg will not break. So egg won't break. Egg won't break. And similarly, why does a cricket fielder pulls his arms while catching a fast moving ball? See, the ball is coming with certain speed. Dhoni or Virat Kohli, somebody has hit the ball hardly and is coming with a greater speed like this, like a jet it is coming. If you stop it suddenly, the interaction time between the cricket ball and the hands is very less. Whenever the time is less, exerting force is more. Force is more means hands may get injured in that case, because ball exerts more force on the hand also should exert the same amount of force on the ball, and it may hurt your hands, it may hurt the hands of the player, so he drops the catch. That's why he does not stop the ball suddenly. He pulls his hands back like this. So means he is increasing the interaction time. When he is increasing the time of interaction, slowly he is bringing the ball to rest. Somewhat he is taking more time. So he is taking more time to bring the ball to rest means as time of interaction increases, the force experienced by the hands will be less, so he can take a safe catch. So that is, a brilliant fielder will always pull his hands back like this. Okay, so that's the reason for this one. Similarly, why does a pole vault jumper land on thick mats of foam? Thick mats of foam. So with a stick he will go and fall on the mat. After falling on the mat, his momentum will be zero. Before falling on, this is the mat and he took a jump like this. Before hitting the mat, he will gain some velocity, he will have some mass, he will have some momentum. After hitting, momentum will be zero. Means there will be a change in momentum. So from the definition of impulse, change in momentum will be the product of force into time. So on the mat he will move up, down and like this finally comes to rest. So he covers more distance. So like this, it takes more time to come to rest. Time is more, interaction force will be less. So nothing will happen to that pole vault jumper. And why it is safe to jump on a sand rather than a cement floor? So when we jump on a cement floor, somebody jumps on the cement floor, so there he will come to rest quickly. So time is less, interaction time is less, large amount of force will be exerted, so he gets injured in that situation. But when you jump on the sand, our legs pass into the sand, slowly you will come to rest. So time of interaction increases, force is less, so we do not get a hurt. So we can take a safe jump. So these are the examples of impulsive forces. Impulsive forces is nothing but large amount of force acting on a body in short interval of time. The product of that force into time gives the impulsive forces. Okay, and that is also called impulse, we can write. Okay children, and my kind request to all students who are observing the videos, please go through the textbook carefully and talk to your parents every day in a polite manner. Please learn the good habits and say what the great things you have done from morning wake up time to the evening, that is going to the bed. Please speak with your parents, mother, father and elder brother and elder sister, and see there should be a good development for every child. please learn a good moral values and talk to your grandfather, grandmothers in a polite manner. Get good habits. Thank you. We can again interact with another lesson. Thank you, students. Good night.